It's from Peter Jennings' Seeing is Believing. It's about pilot sightings of UFOs. And what we need to pay attention to in this video, and in order for us to make that connection between modern physics and UFO technology, are some of the strange characteristics of UFOs. In fact, that's what makes a UFO a UFO, are these unusual characteristics such as the incredible acceleration of these objects. And Ted Phillips of MUFON, an investigator for MUFON, had done a study of landing sites where UFOs had landed, and he estimated that UFOs were in the range of 20 to 30 tons, and yet they can do these absolutely phenomenal accelerations. Another really strange characteristic of UFOs is many people have reported UFOs becoming partially invisible. They can see through them and then totally disappear, literally right in front of their eyes. And one of the witnesses in this, one of the pilots in this DVD saw exactly that. If we're going to understand UFO technology, we have to be able to explain those characteristics. And so I'll start this DVD here.
It was the beginning of the Cold War, and what Americans feared most was being attacked by the Soviet Union.
We didn't know what they might have flying. And so those concerns by the government, legitimate concerns by the government for our security, led eventually to them establishing a full-time office to investigate UFOs.
The Air Force investigators quickly came to realize that they were not dealing with Soviet aircraft. Nothing man-made performed like flying saucers.
They started thinking, well, the Soviets aren't doing this. There's really no thing on Earth that can be doing this.
And then on July the 24th, 1948, two experienced commercial pilots, Clarence Childs and John Whitehead, were flying at night over Alabama when they encountered what they described as a cigar-shaped object, perhaps 100 feet long, flying faster than any aircraft they had ever seen. It had, they said, 2 rows of windows, and they could see lights inside, and orange-red flames shooting out of the tail. Air Force investigators couldn't explain it.
It could not possibly fly unless it had an engine in it that was beyond anything anybody on Earth could make. And this, in a sense, was their proof that they were dealing with the extraterrestrial technology.
The Air Force investigators trusted the testimony of these experienced pilots and were forced to consider the incredible. Since 1948, there have been thousands of sightings by commercial and military flight crews.
March the 12th, 1977. I was flying a trip from San Francisco to Boston, and I was stopping at DC-10.
It was an Airbus 320, and we had 24 passengers on board with very good condition. We were at 39,000 feet.
We were just north of Dallas, Fort Worth. It was a beautiful, clear night.
Out of nowhere, some lights appeared. Looking over to the left of me, just to the north of me,
I noticed a red light of some kind to the the distance off our port side, our right side.
And Larry says, well, keep an eye on it. He says, well, now it's coming at us.
And they began to turn from pointing directly at us in an echelon sort of a turn away.
It was not a plane, it was not a weather balloon. It was huge, absolutely huge. It was dark red color. And so this object began to become transparent and it disappeared. It was absolutely crazy. Crazy.
It just was gliding through the sky so quietly, and as it did so, it blotted out the stars behind it. It just reminded me of a submarine in the depths when it's quiet and just kind of motoring right on through, you know.
There were no wings, there were no windows, and it was cigar-shaped.
I saw what I saw, and this thing was not from here.
I watched this big, gigantic light
go out behind our left wingtip, and then as the turn progressed, it disappeared in the distance off to the back at a very high rate of speed. I've flown all the jets. I flew in the war. I flew B-17s in the war. Everything. I've got over 30,000 hours of flight time, and never had a sighting as that one. So it was once in a lifetime.
As you can see, there's a tremendous amount of UFO evidence, and it literally from the 1930s at least, right up here into the 21st century. And these are very, very credible reports. So there's really something going on. And one other characteristic, or a few other characteristics that we need to pay attention to as far as the UFO phenomenon is concerned. As I mentioned, the inertia-defying rapid accelerations, and of course the intense glow and their ability to levitate. And even though it appears they weigh 20, 30 tons, the typical smaller 30, 50-foot disc-shaped UFOs. And another characteristic being they're partial and then becoming completely transparent. This is very, very interesting, as we'll see. And another very puzzling characteristic is at close range, a strong, attractive gravity field, which doesn't seem to make any sense, because you would think if they're using something like anti-gravity, that they would be repulsive and pushing things away. But instead, the opposite is true. At least at very close range, they see objects lifted up underneath these craft, and when they go over the ocean or a lake, if they get close to the surface, they'll see a huge, massive mound of water lifted up under the UFO. So if we're going to, as I mentioned, if we're going to understand UFO technology, we're going to have to explain that characteristic. And then another thing that's very interesting is the consistent shapes. They're typically spheres, discs, cylinders, and lately we've been seeing the triangles. Here's another really interesting case, Captain Phil Schultz, and over Lake Michigan in 1981 on a perfectly clear summer day. And he was flying at around 30,000 feet, and he and his crew observed a UFO literally come straight down in front of their craft at over 1,000 miles per hour, do a 20G turn, and keep in mind the best that we humans can do is about 10 Gs, and that's only with a lot of training, and with a G suit, fighter pilots can do 10 Gs. But yet, this UFO did a 20G turn right in front of their L-1011. And here's the cockpit view of that, and you can see the UFO came down from the upper right, made a sharp turn, and disappeared over this way. They actually thought they were going to collide. They braced themselves for a collision. But Captain Schultz's reaction was extremely interesting. He had extensive experience in the U.S. Navy as a fighter pilot, but after this encounter, he told Dr. Richard Haynes, a NASA scientist, that there is no doubt in my mind it was an extraterrestrial craft. Pretty amazing. Here, of course, is Captain Duboc's sighting of the one over France that became partially transparent and totally disappeared. Now, that was back in 1994. But here's a much more recent sighting just a year ago in Canada near Calgary. A corporate pilot observed a typical cylindrical shaped UFO, and he was able to see the road, after watching it for a few minutes, he was able to observe the road right through the UFO before it disappeared. So the two big questions on UFO technology are, number one, how did they get here? And number two, how do they perform these inertia-defying acrobatics in Earth's atmosphere? And we'll look at the question of how do they get here first. Well, scientists have spent quite a bit of time wondering about how it might be possible to do interstellar flight. And they've basically narrowed it down to 3 ideas. If we could somehow go faster than light, if we can go near light speed, or if we could somehow warp space-time. But the problem with all 3 of these methods, which is acknowledged by the scientific community, is huge amounts of energy are required. Like on the last one there, warping space-time, a Mexican physicist by the name of Miguel Alcubierre, many of you may have heard of him, came up with an idea of warping the space-time in front of and behind a spaceship that would allow the spaceship to travel on almost like a wave through space-time. But later, many years later, after much further investigation, I can tell you general relativity is pretty difficult, the equations and stuff, which we'll see here in a second. And he decided that it wasn't feasible, at least not with what we know now. And anyway, so if we're going to understand what's going on in UFO technology, we're going to have to first take a look at, we've looked at the UFO evidence, now we're going to have to look at what's going on in modern physics. And at this point, I have some good news and bad news. The bad news is we're going to have to do some physics, but the good news is there will be no quizzes or exams. So just everybody relax, sit back, and enjoy. So the 2 pillars of modern physics are general relativity and quantum mechanics. General relativity explains the force of gravity, and it explains it as a result of the warping of space-time due to the presence of matter and energy in a region of space. And so that general relativity explains one of the 4 fundamental forces in nature. Quantum mechanics explains the world of the very small, subatomic world, electrons, protons, quarks, things like that. And it also explains the other 3 fundamental forces in nature, which are the strong nuclear force, which keeps the nucleus together, the weak nuclear force, which is responsible for radioactivity, and electromagnetism, which we're all familiar with. And let's see. And it just so happens that 2015 was the 100th anniversary of the publication of the field equations of general relativity. And and I believe gravity is going to be a key to understanding the UFO phenomenon. And here are the actual field equations. And on the left side here, this describes, in the field equations, this describes the curvature or the warping of space-time, which creates what we call gravity. And then on the right side, that tensor right there, and modified by this constant here, describes the mass and energy in a region of space that is responsible for the warping of space-time. And let's see. And now, unfortunately, the field equations are very, very difficult to solve. And this will give you some idea of how difficult they are to solve. And if any of you have ever worked with the field equations, have no doubt had to work your way through these things. But this equation at the top is exactly the same as on the previous page. This is the what are the summarized field equations. They use tensor notation. And you may have noticed that I used plural with an S on the end there because it's a cascade of equations. Man, you're not going to believe this. And so I colored in the first term in red, and then I expanded that so you can see what that consists of. But keep in mind that each one of these terms also blows out into a cascade of equations. And then on the second equation here, there's the equal sign. On the second equation here, which is from this term alone, I took that term and blew it out here, and you can see that that blows out to something else. So you're getting some idea. When you solve even for a relatively simple problem in the relativistic physics, it can be 160, 200 equations. And that's not the whole of it. Unfortunately, for that first equation that you saw on the previous page, and this is the same equation right there, I just abbreviated the first terms there. But you have to have 10, you end up with 10 independent equations, and you have to solve those simultaneously. So you can see playing with the field equations is not easy, you know. However, when these were first published in 1915, in the fall of 1915, scientists around the world were really excited because they had now a tool to look at galaxies and solar systems and the world as a very large, and the universe as a whole, and they could you know, learn how to understand it better. They could develop new theories and so on. And but then as they dug deeper and deeper into the equations and they tried to solve them, they realized, man, these things are almost impossible to solve. So in the next slide, I show the general reaction of the scientific community to the field equations. And this is for real. They were in a state of shock. So what is interesting about this is that in the middle, in March or April of 1916, in the middle of World War I, at that time, everybody was still struggling with the equations, believe it or not, including Einstein. All the solutions to the equations at the beginning, and this is 4 or 5 months after they're published, were all approximations. So you can imagine Einstein's amazement when he got a letter from a German soldier on the Eastern Front in 1916 who had the first exact solution to the field equations. And his name was Lieutenant Carl Schwarzschild, and he had the first exact solution to the field equations. But everybody here will immediately recognize Lieutenant Schwarzschild's first exact solution to the field equations. The Schwarzschild black hole. Everybody's heard of black holes. And basically, all this, what this says here, that RS is called the Schwarzschild radius, and any object with a radius even slightly less than the Schwarzschild radius becomes a black hole. But the thing we need to remember for later on in the slideshow is that photons and any other particle, even though they might be going at the speed of light, the fastest possible speed in the universe, cannot escape a black hole. So keep that in the back of your mind. Nothing can escape a black hole, even if it's going at the speed of light. We'll need that later. And here's an interesting illustration of the very strong magnetic field around a black hole. It's a NASA illustration. It's something you may want to keep in the back of your mind too, because it does come up. Now, quantum mechanics is the other major pillar of modern physics. And basically, quantum mechanics was developed back at the turn of the 20th century, in other words, 1900, because at that time it was thought that energy was continuous like a wave. But then it was discovered that at the subatomic level, at the quantum level, energy can only change in integer multiples of what is now known as the Planck constant. A German physicist who was one of Einstein's instructors, Max Planck, discovered this very strange behavior at the subatomic level. And here's the actual Planck formula, and that's Max Planck there. And here's the Schroeder equation, which is one of the other major equations in quantum theory, and it describes the behavior of subatomic particles in terms of waves. And many of you who have taken a look at physics know that at the subatomic level, particles can behave as either a wave or a particle. It's called wave-particle duality. Very strange feature. So where are we now? I hope everybody's enjoyed these equations. And, and my daughter made me put this in. And if you can't read the caption there, it says more formulas. Oh no, give me another drink. You'll be happy to know from this point on, I'll just be dealing with concepts and doing illustrations, so no more messy formulas. And so, as I mentioned, we have to understand where physics is today. So we're going to do a very quick review of modern physics here. It turns out that our universe is very, very simple. In a nutshell, there's only three fundamental components to everything in the universe. That's it, just three. There's matter particles, there's force particles, and there's the space-time, which is the stage on which these subatomic particles interact with one another. And it creates all the, everything we see around us is all created by just these three components. And as far as the matter particles, people have, of course, have heard of electrons, protons, neutrons, and quarks. And then force particles, photons, carry the electromagnetic force, and gluons carry the strong nuclear force. And we'll just do a quick review here. Here's a basic atom. The simplest atom is a hydrogen atom with no neutron. It's just a proton and an electron. And but I showed this it's an isotope of hydrogen called deuterium. But the reason I showed this is because I want to illustrate the electromagnetic force that holds the electron and the proton together, so that and the electron orbits the nucleus of this atom, and it's attracted to the proton. And let's see. And then here's a quark. I'm sorry, a proton. And the proton is made up of three quarks, which are the subcomponents of protons and neutrons. And you don't have to memorize all this, it's just a quick review. There's two up quarks and a down quark. And then these quarks are held together in the nucleus by gluons, which carry the strong nuclear force. And then here's a very quick summary of the matter particles. What's amazing, when you study physics, there's not that much to memorize, you know. It's, which is really great. And it turns out that there's only four fundamental particles in the universe: the up quark, the down quark, the electron, and the electron neutrino. There are two other families, but these two families here, the second and third, are just higher energy versions of the first. And almost as soon as they are created, they decay quickly back to the first family. So that's it. There's up quarks, down quarks, electrons, and electron neutrinos, and that's it as far as matter particles. And then there's only four fundamental forces in nature: the strong nuclear force, weak electromagnetism, and gravity. And they're carried. The strong force, as I mentioned, is carried by 8 types of gluons. The weak force is carried by the W+, W- and Z neutral particles. Electromagnetism is carried by the photon, and gravity is carried by a hypothetical particle called the graviton. We've never seen a graviton, but we've detected all these others in particle accelerators. There is something called a Higgs field, which I'm sure people have heard of, And that's a background field that permeates all of space-time and is responsible for giving mass to all the subatomic particles. Now, it turns out that physicists, of course, are interested in both matter particles and force particles, but here's where things start to get interesting. But they're particularly interested in the force particles of nature because the force particles make things happen, like the electromagnetic force in a lightning bolt. And so it turns out that modern physics believes that the four forces way back at the beginning of the universe were united in a single superforce. So electromagnetism and the weak nuclear force, strong nuclear force, and gravity. And if you ever wonder what physicists are doing with their time, and there's thousands of physicists all over the world, the holy grail of modern physics is uniting the four fundamental forces of nature, both theoretically and experimentally. That's what they're doing. So, and here's a quick review of the evolution of the universe. At the time of the Big Bang, about a billion years ago, all the four forces were united. Then they broke out into the Good force and the gravity force. Good stands for Grand Unified Theory, and that broke out very quickly to the strong and electroweak, and electroweak into electromagnetism and weak force. The four forces we see today that have distilled from the original Big Bang are gravity, strong nuclear force, electromagnetism, and the weak force. Interestingly enough, scientists have made pretty good progress in uniting many of these forces of nature. For example, it was once thought the electric and magnetic force were separate forces, but we now know that they're joined, they're a single force called electromagnetism, and James Clerk Maxwell, the Scottish physicist, discovered the laws of electromagnetism. And really interesting, back in the 70s, they recreated the electroweak force, which is a combination of electromagnetism and the weak nuclear force. And then they're working on trying to reunite the strong nuclear force and the electroweak into the Grand Unified Theory. And they're making some progress on that. But now here's where we start to make the connection to the UFO phenomenon. This is where it gets exciting. You'll notice that only gravity is not included in these attempts at force unification. And why not? Well, here's why not. Because gravity is incredibly weak compared to the other forces of nature. Just to give an example, the weak nuclear force is 10 to the 25 power stronger than gravity. And that's the number 1 followed by 25 zeros. And so, I mean, that's just unbelievably difference in strength. And this ditto for the electromagnetic 10 to the 36 and the strong 10 to the 38. In fact, this huge discrepancy between the gravity force and the other non-gravity forces in nature is such a big problem in physics. It's got its own name. It's called the hierarchy problem. And I believe solving the hierarchy problem is going to solve the UFO enigma, as we'll see. The hierarchy problem is also equivalent to the puzzle of what is known as the weak mass versus the Planck mass. And all that means is that if all the subatomic particles were at the Planck mass, which is much, much heavier, 16 orders of magnitude greater than what we see, if all the subatomic particles were at the Planck mass, then the gravity force would be as strong as the other forces in nature. But they aren't, and we don't know why not. But unfortunately, it's in a way it's a good thing, because if all the subatomic particles in our bodies, in the building here and stuff, were at the Planck mass, the universe would disintegrate. And so that's not a good thing. In fact, it's such a serious problem, I went to an expert to understand the magnitude of this problem. And if you can read the caption there, it says, "You mean my favorite donut shop will disappear?" So Homer without his donut shop would not be Homer. And so you can see it's a serious problem. So we're going to show a potential solution to the hierarchy problem based on what's going on in modern physics. And in a nutshell, this is just simply the evolution of modern physics. And the theories in black up here on the top have been confirmed many, many times in particle accelerators, and we're very confident those are real. Those are correct. You know, general relativity, quantum mechanics, classical mechanics, Newton, and Maxwell's equations and stuff like that. And but now, starting in the 70s and 80s, physicists right up to 2015 here, they've begun working on other theories. And you can see some of these: supersymmetry, 4D, supergravity, 5D, five-dimensional Kaluza-Klein, 11-dimensional supergravity. People may have heard of string theory and stuff like that. And brains, membranes, and extra dimension, strong gravity theories. What we need to focus on in this particular slide is after about the 70s and 80s, they began paying attention to the idea that maybe we don't live in a four-dimensional universe, 3 dimensions of time and 3 dimensions of space and 1 dimension of time. They now suspect we may live in more than 4 dimensions, and that's where these newer theories came from: 11D, 5D, 10D, and stuff. And another thing are the string theories. String theory is another very interesting theory that's come out. And they used to think the subatomic particles were infinitesimally small points. Now they think they're little wiggling strings. And it turns out they think that the strings are open, so they have, of course, 2 open ends. And so that's going to figure into some of the explanation of UFOs in a second here. And then brain theory. It appears that our universe exists on a membrane, a space-time membrane. And so anyway, where physics is today is they actually believe we live in an 11-dimensional universe. But it turns out that 6 of the 11 dimensions are curled up at every point in space-time. That still leaves 5 large dimensions, which is 1 more than the historical 4-dimensional universe we thought we lived in. But theory now suggests that there are 2 4-dimensional membranes floating side by side in the larger 5-dimensional universe. And here's an illustration that shows that. So it looks like all the subatomic particles, the matter particles and the force particles, are open strings that are stuck on the membrane we live on. And they can't escape, except for one particle. And here is pointing toward the solution to the hierarchy problem, the weakness of gravity. It turns out that gravitons in the theory are closed loops. And that means they're not stuck on the membrane. This is our universe where we live on the left side, and it's believed that there's another universe parallel to us, another space-time, and that area in between is called the bulk, B-U-L-K here. And so this is a 5-dimensional universe, but the membranes are 4-dimensional. And so this is very exciting. It didn't at first explain the hierarchy problem, but along came another theory called warped geometry, and it was derived from membrane theory, and it was developed by a Harvard and a Johns Hopkins University physicist, and it explains why gravity is exponentially weaker than the other forces. According to warped geometry, 2 4-dimensional membranes, just like I pointed out there, membranes are in the bulk. One membrane is the one we live on, called the weak membrane. The second membrane is called the gravity brane in their theory. But the gravity brane is warped in such a way that virtually all the gravitons that carry the gravity force in the universe are attracted to that gravity brane. And this explains the hierarchy problem. And what it means is that that's why gravity is so weak on our membrane, because the gravity brane over here attracts 99.99999% of all the gravitons in the larger five-dimensional universe. And the second I saw this theory, it occurred to me, what if UFOs could get off our four-dimensional membrane, penetrate the bulk, and get in far enough where gravity is very strong, because general relativity tells us that where gravity is strong, distance shrinks. And this, I believe, is the solution to how UFOs get to planet Earth. I believe they go into the five-dimensional bulk. They go in deep enough where distances are much shorter than in regular four-dimensional space. And that's what I think they're doing. And so if that's what they're doing, Mother Nature is providing a pathway to the stars. And if you remember that one of the first slides, we don't need huge amounts of energy to warp space-time. Mother Nature does it for us. And this is just an illustration. It shows how distance shrinks as you get into the bulk. And one of the particles that they expect to see in particle accelerator experiments is something called a KK particle, a Kaluza-Klein, which I mentioned earlier. And this particle is a signal that the extra dimensions exist. But the interesting thing, and keep this in the back of your mind, the KK particle, they expect to produce KK gravitons, a different type of graviton, and that carries the gravity force much, much stronger than ordinary gravitons. But the exciting thing is that these KK particles, their natural home is the five-dimensional bulk. They want to go in the bulk. And just like E.T. wanted to go home, five-dimensional KK gravitons, they want to go home too. Their home is the five-dimensional bulk. And that is going to be important to UFO technology. And here's why. I think what the UFOs do is they surround themselves with these KK gravitons, and that's how they pull themselves off the bulk. So these are ordinary standard model particles, protons, neutrons, stuff like that. And it's surrounded by the spaceship is surrounded by KK gravitons, pulls them off the bulk. And that's why we see them disappear. They become partially transparent and then totally disappear. They're going into the bulk. And here's another example of that. Sir Francis Chichester, he was a world-famous pilot. He observed a UFO over the Tasman Sea. And it came on, but instead of increasing in size, it diminished as it approached. When quite near, it suddenly became its own ghost. 1 second, I could see right through it, and the next second, it had vanished. Another example, way back in the 30s. Now here's an example of a UFO getting into the bulk. It shows you how great it would be if we can get in there. Alpha Centauri, those of you who are aware that Alpha Centauri is the closest star to planet Earth, is 4.3 light years. If we can get into the bulk, Alpha Centauri is 25 trillion miles from Earth. The gravity force in the bulk increases by 16 orders of magnitude between the weak or TEV brane and the Planck brane. If we get in there, but we only go into the bulk where the increase in gravity strength in the bulk is only 1/10,000th of the maximum strength of gravity in the bulk, so you're only part way into the bulk. How much does, instead of 25 trillion miles to Alpha Centauri, which would take years with methods we know now, the distance to Alpha Centauri shrinks in the bulk to 25 miles. You could get to Alpha Centauri in your car in half an hour, depending on the speed limit and the bulk. and so Bart, Homer might be skeptical, but it appears that Bart says he goes to Alpha Centauri in just 30 minutes. Yeah, sure. So on the two big questions on UFO technology, how did they get here? Looks like Mother Nature provides a natural warp pathway. And then how are these craft able to perform inertia-defying acrobatics? This is a lot quicker because we have all the background physics. It turns out KK gravitons create micro black holes. Remember, we were looking at black holes way back at the beginning. And these four-dimensional black holes, four-dimensional gravitons, the ones that keep us pinned to planet Earth, are absorbed by micro black holes. So I think these UFOs are creating KK gravitons, which in turn create micro black holes, which in turn swallow the four-dimensional gravitons that communicate the gravity force. So what ends up happening is that the graviton exchange between the Earth and the UFO is reduced. This is not anti-gravity. Instead, the gravity or inertial force is reduced to near zero. And this is just a quick illustration of what it would look like. The KK gravitons in red, then it creates micro black holes. A little more detail on the various interactions that take place. And now here's the exciting part. We've seen these UFOs do 25, 30 Gs, 100 Gs actually. They recorded one on radar doing 100 Gs. And so how do they overcome inertia? Well, the equivalence principle, which is at the heart of general relativity, says inertial mass equals gravitational mass. Inertia is the resistance to acceleration of a body. And the more massive the body, the greater the inertia. So what UFOs are doing, by decreasing the gravitational mass, and gravitational mass equals inertial mass, they reduce the inertial mass, and that is how they're able to accelerate at blinding speeds. And now what's the relationship between the Large Hadron Collider and UFO configurations? The Large Hadron Collider is where they do, it's a huge circular particle accelerator over in Geneva, Switzerland, where it's the biggest in the world. And they've just upgraded it. It's even more powerful than it was. And now UFO, oh, by the way, at the Large Hadron Collider, they expect that we're going to be producing KK gravitons and micro black holes if the extra dimension theories are correct. UFO configurations are typically disks, cylinders, spheres. Even triangle UFOs have bright circles in each corner, as you saw on the cover of the book. So why do UFOs have this circular aspect to their shapes? Because UFOs are particle accelerators. I believe that is what they are. And here's some circumstantial evidence. Two pieces I'll go through real quick here. A UFO observed in Sonora, California in 1976, and a current crisis in physics. The UFO sighting in 1976, people who have followed the UFO phenomenon know what angel's hair is. It's a substance emitted by UFOs, and they find it draped in trees and stuff after a UFO goes by. Well, they found something called tritium, which is another isotope of hydrogen, but it turns out that tritium is rare in nature, but is found in particle accelerators. Isn't that interesting? So that's a piece of circumstantial evidence that indicates that these UFOs are particle accelerators. And then there's a crisis in physics. There's a theory called supersymmetry. You can't read the subtitle here, but it says if supersymmetry doesn't pan out, then scientists need a new way to explain the universe. Well, guess what? Supersymmetry was the theory that physicists have been working on for 40 years. People have devoted their entire careers to it. And it was supposed to solve the hierarchy problem. And it's not working out. They're not finding the particles at the Large Hadron Collider that were predicted by supersymmetry. So the physics world is in a dither over this problem. But that crisis in physics is an opportunity for competing theories. And the failure of supersymmetry means that, which was supposed to solve the hierarchy problem, means that warp geometry by these Harvard and Johns Hopkins physicists now looks much more likely, you know. And by the way, the extra dimension theories have been the black sheep in the physics community. Okay. Okay. And so anyway, the remaining slides here, we'll look at known effects of UFOs, expected effects from modern physics. Can we prove, and where do we go from here? And the effects of UFOs in close encounters, strong magnetic fields. Pilots report their compasses spinning wildly. Number 2, indications of strong attractive gravity field. Number 3, certain types of radiation like high energy radiation. And number 4, observation of UFOs becoming partially or totally transparent. Let's see what the expected effects would be if this, if what's going on in modern physics can explain UFO technology. Micro black holes, interestingly enough, create strong magnetic fields. That's what pilots are reporting. KK gravitons create a strong, short-range, attractive gravity field. What we saw in the beginning, the UFOs lifting water from, or lifting objects near the ground. Micro black holes will decay into something called Hawking radiation, which is high energy radiation, or includes it, gamma rays, X-rays, exactly what we've seen. And an object on our weak brain penetrating into the bulk will be seen to fade and disappear, like Captain Dubach saw and Francis Chichester saw too. Can we prove? Yes. The Large Hadron Collider will give evidence confirming or disproving M theory and warp geometry, and more UFO data needs to be acquired to see if we can detect Hawking radiation. And that's basically what this last slide says. And then here's some interesting pictures of UFOs. I only have a couple minutes, so, and here's a cutaway of the Large Hadron Collider. You can see the detectors here, there's 4 of them, Atlas, ALICE, CMS, LHC, and where they collide the particles together. Here's a view inside the, it's 26 miles in circumference. Huge, $10 billion machine. And here's one of the detectors. You get an idea of how big it is. There's a workman here at the bottom. You can see how big, this is big science. And you'll be happy to know that the security, they are not happy, but you'll be sad to hear that when they first started up the Large Hadron Collider, one of the giant cryogenic magnets exploded, shut down the entire thing for a year and a half. So, but you'll be happy to know that CERN security did a tremendous job, and they finally discovered they found bubblegum stuffed into some of the sensitive electronic components, and they finally discovered the culprits who had brought down the Large Hadron Collider. And I'm only kidding, but that's the end of the show. And,
thank you very much, Robert. It's great to have a perspective from a scientist, and it's through scientists like Robert and others help us to solve the mystery. So folks, something I forgot to add too was we had a paranormal investigation last night put together by the Silent Society of the Paranormal. And we have Mr. Paul Mancha later will share with you some of the findings that they conducted. So we're going to go ahead and take a short 15-minute break. We would like you to be back here at approximately 10:45 and enjoy outside the lobby, and we'll see you shortly.